Hello, everyone. My name is Zurnica Manolova, and together with my colleague Dominic Yani from Glyph and our partners Camille Kunders and Jan Dix from Enteffect, we'll share in today's session our experiences of building an interactive dashboard to monitor the data quality. But before we move to the deep technical part, I would like to describe the problem we had and draw the bigger picture in order to fully understand some of the decisions we made. For this, I will introduce you first to Glyph and the LAI data. I'm just not sure, I'll just make a short break. I'm not sure whether the slides are shown because I don't see this on my screen. Perfect. Thank you very much. So for this, let's start first with who is the Global Legal Entity Identifier Foundation, or shortly Glyph. We are a non-for-profit Swiss foundation founded by the Financial Stability Board. Glyph activities are overseen by the Regulatory Oversight Committee, or for short ROC, which is made up of more than 65 representatives of public authorities from around the globe. Glyph is managing a network of partners, mainly the LEI issuing organizations, and our task is to ensure the operational stability of the global LEI system and to promote the LEI. Currently, there are more than 2.2 million LEIs issued in the system. But what is an LEI, you will ask? LEI stands for Legal Entity Identifier. It is an ISO standard, a 20-digit alphanumeric code, and connects to legal entities reference data, such as the name, the legal form, the address of an entity, and where it is registered. Furthermore, it provides information about corporate actions, children or parent entities, as well as some fund-specific relationship types. So far, this doesn't sound too complicated, right? The data seems to be quite well described and clear, so what can go wrong here? There's just this one specialty. As mentioned, we are managing a network of partners who are distributed all around the world, all following their local standards. They provide us with their entire data pool on a daily basis. We take the data from the different sources and make it available in a consolidated form, free of charge as a public good on our website in order to improve the transparency in the financial sector. But at the same time, we are not allowed to touch, manipulate, edit, or clean the data. And we are responsible for the data quality management. And yes, I did mention public good, data is a public good. The LEI data, with all connected reference data of legal entities information, as you just saw it on the screen, is available as an open source data free of charge on glyph.org. You don't even need to register or create an account. You can just go there and simply search the entire repository via the LEI search we make available, download the files, which are, by the way, updated 3 times a day, or simply use the Glyph API to explore the information about more than 2.2 million entities and their historic updates. As you can see, the data is highly standardized, following different ISO standards and using XML schema definition to secure the file formats. In addition, we have defined the whole data quality management framework to maintain the quality at the required level. For this, we have defined different quality criteria, maturity levels, data quality checks, and what you see on the screen we call data quality gates. We publish monthly reports on the entire data pool, as well as on the individual LEI issuer. And still, we were missing some bits and pieces, some events happening in between reports, And we were surprised at the end of the month when we generated the reports. We were basically sitting on all this data, but we were not fully utilizing it. There came the idea to create an interactive dashboard for monitoring the data quality and the activities of the individual LEI issuers, enabling ourselves to react timely to outlier and single events, and thus to prevent these becoming repetitive and systematic issues, creating unwanted patterns in the data. One of the main criteria for choosing the tool and platform for creating this dashboard was to be flexible, so we can adjust and modify as we see fit in an uncomplicated workflow. And also here, we are following the guiding principle for everything we do of being transparent. So the dashboard we have created is now publicly available, and you can check it out under dq-dashboard.glyph.org. But now, back to the topic of this session. How did we get there?
So if you want to start a web project as a Python developer using open source technologies, you might find yourself in front of a jungle of cool technologies and frameworks that you could use for your project and just might not be sure which one would be the best for your use case. So in this presentation today, we will take you on our decision journey and give you some insights into what we learned on the way and what helped us decide which technology to use. So the first thing you need to build a web project using Python is a web framework. This framework will allow you to connect your backend database with your front-end application using APIs. And there are many cool open source web frameworks available. And here in this next slide, you can see 3 example projects: Django, Flask, and FastAPI. In the table, we pasted some basic indicators that can help you decide if an open source framework is a good fit to build a stable project. For example, you could look at the time of the release, and this will give you the maturity of the project. You could also look at the stars and the contributors of a project, which will give you a feeling for the activity and the community behind the project. And taking these numbers into account, you're pretty much good to go with any of the technologies shown in the slide. It really just depends on your needs, the scale of your project, and the prior knowledge that you have in any of the existing Python frameworks. So in our case, we decided to go for FastAPI. While building the dashboard, we wanted to be flexible and able to experiment on some of the features. In order to do this, we had monthly meetings with Glyph, where they would give us feedback, and it was crucial for us to be able to react to this feedback quickly. And we found that FastAPI really supported us in this and allowed rapid prototyping. This was mainly because the documentation of the tool was really good and allowed developers new to the tool to learn it quickly and get up to speed. And because of this, we decided to stay with FastAPI after we had tested it for the project initially. So FastAPI is built on the Starlet framework, and it also supports asynchronous code out of the box using async and await Python keywords, and this is what makes it so fast. FastAPI is also built on the pedantic type hints to validate, serialize, and deserialize data. So what does this mean? As you can see in the code example we created a type cat. Cat has a name, cat has some attributes, such as age or furriness to describe it. And in the bottom, we have an example API call that would post the cat object to our application if it has the correct type. So if a user, for example, would create a cat object with, I don't know, the age furriness, this wouldn't make sense because age can't be furry, it has to be an integer, and this would fail and it wouldn't be pasted into our application. And this way we can ensure that only the correct values are shared throughout our application. And using this, FastAPI can then also auto-generate open API documents, which is really cool and saves a lot of time, as we would otherwise have to do all of this work manually. So the last 2 lessons that we learned using FastAPI were that it was extremely helpful to use FastAPI's dependency injection system for repetitive tasks, such as yielding a database or formatting pagination parameters. And what we also found that it is best to do any kind of data validation in the endpoints itself. It's totally not necessary to use pandas or any kind of other frameworks for this, because FastAPI really supports this out of the box and you can just save a lot of code. Yeah, so this is what we learned from FastAPI.
So different data sources are the core of our application. In the dashboard, we connect
different kind of data sources. So we have REST APIs, we have relational databases. The question is how we connect to these different data. Today, we will introduce the learnings around relational databases that we have made. However, some of the findings are also easily transferable to other data sources. So let us begin with how we can connect Python and relational databases. So we used the object relational mapping library, in this case SQLAlchemy, to connect Python to MariaDB. Object relational mapping is also called ORM. Of course, you can also just use database APIs without an ORM, but ORMs make it easy to switch between dialects and to switch out databases. But also ORMs allows us to map single database rows, either from tables or database views, to Python objects. Similar approaches are also available for NoSQL databases like MongoDB. We can write queries without writing a single line of SQL, although previous knowledge of SQL helps us to write these queries and also improve the query performance. SQL queries can be written in a Pythonic way so that it can be read by other developers that do not have knowledge of SQL so that they can be easily onboarded. Also, the ORM helps us to express complex database relations and to easily query them. So the ORM in general reduces the complexity, but not only in querying data, but also in the way of how to connect to databases and to simplify transactions with the database. So in the code example, you can see a small example how we query the database table checks and how we link the check tags to this database without defining a join. This all automatically happens in the back. And then this is automatically translated into Python objects. So how can you decide which library you want to choose? So you're probably familiar with all the different database libraries or ORMs that are available in Python. So we have SQLAlchemy, which is a very mature project. We have Tortoise, which tries to translate the Django ORM-like style into an async framework. We have Pony ORM, which allows you to write SQL in a more Pythonic way. And here, as previously said, you should go with the framework that you're most familiar with and that fits your use case. If you're already using Django, you probably want to stick with the Django ORM and don't want to change this. You can also additionally see here how many questions have been asked on Stack Overflow. The results for Django ORM are not displayed in for Pewee, but for the other libraries. And as you can see, for SQLAlchemy, you find a lot of questions and answers on Stack Overflow. In the beginning, we decided to go with Orator ORM, but this is not supported anymore, and therefore we decided to switch to SQLAlchemy and to replace some of our older code and rewrite that code using SQLAlchemy. Coming to the learnings. So something that we noticed from the very much beginning is that migrations are a very powerful tool that ensure the continuity of your service. So when you want to change anything in your database structure, you probably want to use migrations to do that, to ensure that your service is still running after you change anything in the database. Something that we've also noticed is that it's really helpful to aggregate as much of the data in the beginning and use materialized views that are updated by triggers, for example, at night. Aggregating the data in the beginning increases the query speed and hence increases the speed of your dashboard. Then we also noticed that it's really clever to check whether a framework is still supported before you start coding your API. In our case, we noticed quite late that Orator ORM is not supported anymore and that we had to switch to SQLAlchemy. That also applies to another learning that we had. So you should pay attention when selecting your framework, whether all the statements and operations that you are planning to use are supported by the library that you're choosing. In our case, we had to write a lot of raw SQL in the beginning because Vato ORM was not supporting some more complex SQL statements. So, and then last but not least, we noticed that the performance mostly depends on the database setup and the queries that you write, of course. And you should start optimizing once you are able to measure performance. So when you have a query, you can benchmark that query. It makes sense to start adding indices and setting improvements. But thinking about the query performance in the beginning is in most cases not possible and not very helpful. Coming to the next point is processing data. So as we already said, we had a lot of different data sources, and we said we want to aggregate that data in an early stage. But how do you do that? In our case, we use task queues to execute computational heavy tasks overnight. So we have some complex business logic, such as the data quality score that you also find on the start page of the dashboard, that aggregates different data sources and then calculates one single score. Therefore, we need, as I said, to combine different data sources, different database tables, and collect all this data and then calculate the score. What happens is that we queue this as jobs in the night, and this is running in the background using multiple workers so that it can be parallelized. So you might ask now, why not just use cron for that and have your Python script and just execute it with cron? And after some researching, we noticed that cron in Docker is a challenge and it's not the most easy thing to do. So we decided to use a task queue and to use Celery. For task queues, you also have different options. We decided to go with Celery because the ecosystem is quite strong. I come to that later. But if you're looking for something smaller, something simpler, there's also the Redis queue, there's Vue, and here again, use the framework that you are familiar with, and also probably speak to other developers, ask them what they have used, what they have made experiences with, and what they would suggest you. You can also look into solutions outside of Python, for example, Kafka or Amazon Simple Queue services, which provide APIs for Python. So why have we chosen Celery? Celery provides a really strong ecosystem. So we have the Celery worker that can be started in a Docker container. We can start multiple instances of that and then execute tasks in these different workers. On the right side, you'll see a small program that wraps the data quality score calculations into a task. And then in line 13, you can see how you can then asynchronously start this task and let this task run without any interruption in the main program. You also find Celery Beat that we've also started in a second Docker container then, which allows you to schedule tasks hourly, or you can run that specifically at night. In our case, we use that to start our calculations if we know that all data has been transferred to our data sources. And last but not least, we have Flower, which is a monitoring tool, which is built on top of Celery, which allows you in a graphical interface to see how many tasks you have queued, how many tasks have been started, how many tasks have been closed successfully, and how many tasks might fail. So what are the learnings of working with Celery or working with task queues? Because I think most of these learnings can be generalized to other task queues as well. So what we have noticed in the very beginning is that it's nice to have nice small jobs that always yield the same result, that are deterministic. You should also anticipate from the very much beginning that your jobs will fail. And they're probably not fail because they're written in the wrong way or you have made a mistake, but you have dependencies, you have other data sources. You might have network errors. And therefore, always make sure that when you write a job, that when you restart the job, that it yields the same result and does not affect any other results. Then also there is exception handling. So Celery is very powerful in exception handling. You can catch a lot of different exceptions. You can handle errors differently. And if you want to get deeper into that, I recommend the Celery Task Retry Guide by Ines Parker, which provides a deep insight on how to set up exception handling with Celery. Something that we also learned is it's very nice to have different queues, probably one queue for tasks that are very slow or take longer, and some for more speedy tasks, because then you don't block your queues and you make sure that all your tasks get processed in a timely manner. Finally, we decided to use Redis with Celery. When we started this project, we worked with RabbitMQ, but we noticed that Redis can also be useful in other parts of our application, and therefore we switched to Redis.
So let's talk about monitoring. Our learnings regarding monitoring can be summarized with the more the merrier and the earlier the better. Simply because if you already have a monitoring system in place in the early stages of your project, it already helps you with debugging. In our case, in the beginning, we only used Sentry, and then later on, we added also Prometheus, Loki, and Grafana. We are aware that depending on your setup, Sentry could cost some money. However, we learned that it is worth it because with Sentry, you can basically introduce a monitoring system with a single line of code. Now, let's come to our last slide. What are the overall learnings of this project? So over the last 3 years, we have collaborated with Effect to create this data quality dashboard that you can see on the right-hand side. And especially in the beginning of a project, we had many design iterations. So we had many different prototypes. And the reason for that is we as SQLAlchemy, we were just sitting on this bunch of data, and we just wanted to go away from having CSV files and from only having monthly snapshots. Instead, we wanted to have something where the users can actually interact with our data and where we can get a daily update on what is actually happening. And it was very hard to imagine what is actually possible in terms of dashboards. So only if you actually see the first draft, if you can play around with it, only then you get more ideas. Therefore, you should always acknowledge that there could be some back and forth during the development process. Then the second thing we learned in this project is that it makes sense to involve all stakeholders as early as possible. So as Zonitsa mentioned in the beginning, our data is actually managed by 39 local units that are distributed all around the world. These local units are actually managing the LEI data, and they are also responsible for fixing any data quality issues. That means these units are currently using this dashboard on a daily basis in their daily operations to identify data quality problems and to understand them. Other stakeholders are basically you, the public. So you can actually go on this website, on this dashboard, and you can look at our data and you can verify if there are any potential issues with it. And from an internal point of view, the stakeholders are also our IT admins, who, well, they need to be involved as soon as, for instance, you want to make this dashboard public, because it makes a huge difference if you only have a small number of users or if you open the floodgates, so to say. And the last learning of this project is having regular release cycles. Having a regular release cycle is quite convenient because you always have resources allocated, you have a process in place, and in our case, we will release an update once a month. And in some cases, this could be something small like relabeling something, fixing small bugs. And in some cases, we are actually extending our LEI data or our data quality framework. So maybe we want to add some bigger features, some new visualizations. And it's just quite convenient knowing that there's already something, some resources allocated, and there's a process already there to do this. And of course, it's a very nice excuse to talk to our friends from Effect. And yeah, that's it from our side. Please let us know if you have any questions for us or if you would like to share any feedback with us.
Yeah, thanks for the talk. It looks like we've got a couple of questions down there. Have you seen this one? Thank you, Flow OS. Thank you so much. I built a containered cron SQL job last week, and I'm looking for an alternative. Is that something you have an opinion on?
Yeah, so I think any of the task queues that we presented are probably feasible of doing that. The question is if you want it scheduled or if you want to trigger it from another application. If you want to trigger it by time, I think if you want to have a really simple setup, you can just look at Redis queue, set up a Redis container, and then have Redis queue running, and you can schedule it. I think with the decorator, so it's quite easy to set it up.
All right, thank you. And from Parker Kane, apologies if this was said already. What did they use for a front end for this dashboard?
Camille, do you want to take this? I think you've worked on this.
Yeah, so we had a Vue front end with Vue.js, and we used Vuetify to build the components with Vue.